the next part, number 32, I have a feeling we may get to this and part of 38, and I may just push to the end. How does the entropy of a system change when the temperature of the system increases? Well, the molecules move faster when temperature increases. Okay, so when temperature increases, then molecular speed also increases. Okay, so that means more randomness. So entropy goes up. So temperature increase, entropy increases. How about the volume of the gas increases? That gives more room. So if volume increases, again, it's the same idea. Then there's more microstates because there's more available space for the molecules to spread out to, which means that you have more randomness then, more microstates. Remember, there's this thing called microstates where we take a snapshot of how the molecules are, and every snapshot we take where they move even just a little bit is a new microstate, which means randomness. Increase in randomness. That's not it. Sorry. Let's keep going. Keep going. So how about when a solid dissolves? Again, that means that my solid like this changes to, so more than one, so I have 1 mole of that and 1 mole of that. When I start with 1 mole, it's more particles. More particles means increase in randomness for delta S. That's a delta. That's a, shut up. Okay. So again, all of these things that we're talking about, a solid dissolves in water. That means we have more particles because we have 1 mole of this and 1 mole of that. And then over here, more particles means more randomness. More volume means more randomness, and higher temperature means more randomness. Okay, how about 38? For each of the standard pairs indicates which substance processed the larger standard entropy. Which one has a higher entropy? So 1 mole of P4 at 300 degrees Celsius at 0.01 atmospheres, or 1 mole of AS4 at all the same stuff. So this is the same, that's the same, that's the same, that's the same. So the difference is this and this. Typically, when you have, there's going to be the same number of particles because they're both 1 mole, which means 6.02 times 10 to the 23rd particles. That's what a mole means. However, arsenic is 74.9 grams per mole, whereas phosphorus is 15 point, nope, that's not it, 15.0, 30.97, okay? 30.97 means 31.0 grams. Notice the difference between these two, that's grams per mole. So that means typically the higher mass is going to have more randomness. Okay, typically higher mass means more randomness. That is one of the, we don't use this very often. If everything else is the same, higher mass means more randomness. Okay, 1 mole of H2O at, okay, so these are the same. 1 atmosphere and 1 atmosphere and 1 mole are the same. So everything's the same here except for gas and liquid. This one's easy. Okay, the gas is going to have a higher delta S always. So that would be this one here has a higher delta S. Okay, 0.5 moles is the same here. 298, is that the same? I assume 298 doesn't change for either one of them. Maybe I just forgot to type that into this problem. So what does change? N2, again, 220 liters is the same. So N2 here is 14 times 2 is 28, and CH4 is 12 plus 4 is 16. Okay, so that means that a higher number of mass looks like it's going to be, this one here is going to have the higher delta S. I think there's more to this though, isn't there? Let's keep going. So I got D, 100 grams or 100 grams. So let's take a look. 100 grams of this, it's solid. 100 grams dissolved. We just saw, okay, this is the same. The difference is S solid versus aqueous. That's a Q. And that means automatically our delta S, our higher delta S, goes with the aqueous. Okay, let me just check to make sure, see if there's anything else. Nope, that looks like that's it. And I'm less than my, within 20 seconds. Okay, well, I can tell a joke. So what's the difference between snowmen and snow women? Snowballs. Ha, okay. Guys, thank you for paying attention.